Hi, welcome to this lesson on Euclidean geometry, the circle theorems, center, and chords theorems. So let's have a look at question 2. In the circle with center O, we have that OQ is perpendicular to PR. We also have that the length of PR is 12 units and the length of SQ is 2 units. Determine the value of X. So, what are we given? Let's state that down first. We are given a circle with center O. So that's really important, the fact that we know the center. That enables us to use any theorems that have center in the description. So we have circle with center O. We then have that OQ is perpendicular to PR. We also have the length of PR is 12 and the length of SQ is 2. So the goal is to find the value of X. Okay, so let's start our mathematical proof here. So, first of all, I know I have a center and a perpendicular line from the center to a chord, PR. So that enables me to use a certain theorem. So I'm going to put a 90-degree angle in here because that was given. And I'm going to conclude the following. I'm going to say that PS, the point of contact here, is equal to SR. And my reasoning, perpendicular line from the center O to chord PR. So that theorem tells us that if the perpendicular line is drawn from the center O to that chord, it bisects the chord, which means that it cuts that chord in half. So PS equals SR. But we know that PR is equal to PS plus SR, and that must equal 12, and that was given information. So I use that given information, I've used the fact that it's perpendicular, and I've used the fact that we have a center. Okay. But these two are equal, so if I call them x each, I therefore have 2x equals 12, therefore x equals 6. So each of these are 6. PS equals SR equals 6 units. So there's 6, and that is 6 there. What else? Well, if I look carefully, I have a right angle triangle inside that circle. Okay, so at the point S, O, and P. We know that PO is given as the value X, that's what we're trying to find. OS, we don't know that length just yet, and PS we calculated as 6 units. So if we can just figure out what this is, then we can probably use the Pythagorean theorem to solve for X. But now, the only information we haven't used yet is that SQ equals 2. So this little length here is 2 units. How does that help us? Well, we notice that OQ is equal to X because it is a radius, right? So a point from the center to the circumference, that entire length there is X, because we also know that OP is a radius and that length is X as well. So radius length, and you can say OP equals X is given. Okay, but how does that help us? Well, we know that the full length of OQ can be written as OS plus SQ. But OS, what we're looking for, and SQ was 2 units. So I therefore have this equation that OQ equals OS plus 2, but OQ is equal to X. So therefore, I have X equals OS plus 2. If I subtract both sides by 2, I now have a length of OS in terms of X. So this full length here can be written as X minus 2. Now we can use the Pythagorean theorem and solve for X. So how do we do that? So I can say by Pythag, see, everything you do has to have a reasoning, a logical reasoning behind it. So by Pythag, we have X minus 2 all squared plus 6 squared equals X squared. Okay, so now we have an algebraic equation where the unknown variable is X. So now we get our algebraic toolkit and solve for X. So let's expand the X minus 2 all squared. That is X minus 2 times X minus 2 plus 6 squared is 36 equals X squared. So if I distribute this out, I get X squared minus 4X once I've grouped the like terms, plus 4 plus 36 equals X squared. Okay, so now on the left hand side, what do I have? X squared minus 4X plus 40. Okay, because 4 plus 36 is 40. Equals x squared. Now x squared I can subtract from both sides and they will cancel. So now I have negative 4x plus 40 equals 0. I can add 4x to both sides and therefore I get 40 equals 4x. And then lastly I can divide both sides by 4 and therefore get x equals 10. So the length of OS here is 10 units long. No, mistaken, sorry. The length of OP here is 10 units long. The length of OS was x minus 2. So 10 minus 2 is 8 units long. So we have the classical 6, 8, 10 right-angled triangle. Okay, so we've successfully solved the goal. We found x in this scenario. So we used all the given information from the question, first of all. We then used the correct theorem. We used all our logical, deductive, and reasoning for each step that we have claimed, and therefore, at the end, used our algebraic methods for solving an equation and finding x. So can you see how much mathematics you used in one question? Everything is linked, from your algebra to your trigonometry by using the Pythagorean theorem, from the logical reasoning of Euclidean geometry. Okay, all of it is connected. Nothing is done in isolation in mathematics. Awesome. I'll see you in the next one.